Hi students, welcome to Sangat Learning Classes. In this session, we'll be discussing 3-mark questions of chapter Vector Algebra. So this is the last session of the chapter Vector Algebra. Okay, so we have already discussed 1-mark and 2-mark questions that are asked from this chapter. Alright, so moving on to our first question. So the first question is, find the unit vector perpendicular to each of the vectors vector A plus vector B and vector A minus vector B, where vector A equal to 3i plus 2j plus 2k and vector B equal to I plus 2j minus 2k. Okay, so this is first question is you have to find out a unit vector that is perpendicular to which of the vectors A plus B and A minus C. And what are these A and B vector? It is given in the question, right? Vector A and vector B is given. You have to find out a vector that is perpendicular to vector A plus B and vector A minus B, and that perpendicular vector should be a unit vector also. Unit vector means the magnitude should be 1, right? So what are the things that you have to find out here? First, you need to know the vector A plus B, right? Vector A and vector B separately are given. First, you need to find out A plus B. Then you need to find out vector A minus B, right? Then you will get two vectors, right? Then you have to find a vector which is perpendicular to those two vectors. You will get two vectors. You have to find out a vector that is perpendicular to both of those vectors and of magnitude unity. Magnitude 1. Okay, so which means what is the first step? Think step by step. Okay, first understand the question and think step by step what all things you have to find out here. Okay. Suddenly you cannot find a unit vector which is perpendicular, which is of magnitude 1 and which is of perpendicular to A plus B and A minus B. So you have to do it by step, right? So first you will find out A plus B, vector A plus B. You can find out vector A plus B, right? So what is vector A plus B? How will you add two vector? Just add their corresponding components. So what is vector A? Vector A is 3i plus 2j plus 2k, right? Plus, what is vector B? It is I plus 2j minus 2k. I plus 2j minus 2k. Now what you have to do? You have to add the corresponding components. That is, you first take the I component. What are the I component? The first vector, it is 3. And what is the I component of the second vector B? It is 1. That means 3 plus 1. It is 4i. That is 3i plus I. That is equal to 4i. That's how you will find out the vector, addition of vector. Okay, then 2j plus 2j, second component is j component, right? So 2j plus 2j, what is it? It is equal to 4j. Okay, then 2k minus 2k. What is 2k minus 2k? 2 minus 2 is 0. 0k means you don't need to write that component, right? So it has the A plus B vector. A plus B has only two components, which are those component I component and j component. And what are the scalar components? It is nothing but 4 and 4. 4i plus 4j. Alright, now we are moving on to the next step. And what is the next step? We have to find out A minus B also. We have to find out A minus B. What is A minus B? You have to subtract those two vectors, vector A and B. Okay, minus I plus 2j minus 2k. Since it is minus, we know the sign of the second vector. The sign of the second vector changes, right? It is minus I minus 2j, then minus 2k will become plus 2k because you are multiplying it with a minus 1. All right. Now, what are the components here? You can see clearly, you can see the component is 3i minus I. 3i, what is the answer? 3i minus I. 3i minus I is equal to 2i, right? 2i, then 2j minus 2j, it is 0j. So you don't need to write that component. Then 2k plus 2k, that is equal to 4k. That is equal to 4k. So which is our vector a minus b, it is 2i plus 4k, and vector a plus b is equal to 4i plus 4j. So we have got vector a plus b and vector a minus b. Now what you have to do, you have to find out a vector which is perpendicular to both of these vectors. A vector which is perpendicular to both of these vectors, and it should be of magnitude 1. So first we can find out a vector which is perpendicular to these vectors. How will you find out a vector which is perpendicular to two vector a and b? Vector a and b, it is nothing but vector a cross b, isn't it? It is nothing but vector a cross vector b. Vector a cross vector b will give you the perpendicular vector which is perpendicular to both a and b. Both a and b. A cross b is a vector which is perpendicular to both the vectors a and b. Alright, so first we need to find out a cross b, and here what is a and what is b? What is vector a and what is vector b? A plus b and a minus b. We have already found out those vectors, right? So we have to find out vector which is perpendicular to a vector a plus b and vector a minus b. Here you can see that instead of these two vectors, it is a plus b and a minus b. So it is equal to, we know it is equal to, it is not equal to vector a plus b cross vector a minus b. How will you do a cross product of two vectors? You find the determinant value. And what is a plus b? What is vector a plus b? A plus b is equal to 4i plus 4j. And vector a minus b is equal to 2i plus 4k. From this you can write the components, isn't it? The components are, first components are 4, 4. Then k component is 0. Then next is 2, 4. Okay, it is 4k, right? It is 4k. So it is 204. 2i plus 4k. It was 2i plus 4k. So the components are 204. Now you know how to find out the determinant, right? That is I into 4 into 4 is 16 minus 0. Then minus j into, now you have to remove this column and this row. So what is remaining here? 4, 2 and 0, 4. That is 16 minus 0. Okay, 16 minus 0. Then plus k into, then here you have to remove this column and this row containing k, right? So what is remaining? 4 into 0 is 0, minus 2 into 4 is 8. That is minus 8. Alright, so this is equal to 16i minus 16j minus 8k. Minus 8k. 16i minus 16j minus 8k. Let this be a C vector. Okay, let this be C vector. Okay, so vector C is equal to 16i minus 16j minus 8k. So this is a vector which is perpendicular to both a plus b and a minus b. Since it is a cross product of those vectors, that vector will be perpendicular to both of those vectors. We have got a perpendicular vector, but can we stop here? No, we have to make it a unit vector also. So how will you make this vector C a unit vector? Just divide it with its magnitude, right? Just divide it with its magnitude. So unit vector C is equal to vector C by magnitude of vector C. And what is vector C? 16i minus 16j minus 8k divided by root of 16 square plus minus 16 the whole square plus minus 8 the whole square. So that is equal to 16i minus 16j minus 8k divided by root of now you have to know the multiply 16 with 16. If you don't know the value, then you'll get 16 into 16. Okay, so 36. So 1 6 are 6, 6 plus 3 9, and then 6, then 1, so 6, then 10. So it is 256, right? So 256 plus 256 plus 64. Okay. Now on adding all these, we'll get it is 518, then plus 4 will give you 524, then 60 also. That is, so it will be in total it will be 576, right? So that is 16i minus 16j minus 8k divided by root 576. It is root 576. All right. So this is equal to, we can take the next page. Okay. This is equal to 16i divided by root 576. We know what is the value. It is 24, right? So 24 minus 16j divided by 24, then minus 8k, right? 8k divided by 24. So what is the value? You can cut short it by 8, right? So it is 2 by 3i minus 2 by 3j minus 1 by 3. Right, 1 by 3k. So this is a unit vector, okay, which means it has magnitude 1 and it is perpendicular to both of the vectors, vector a plus b and vector a minus b. All right, moving on to our next question. Find the area of the triangle whose vertices A is 1, 1, 2, then B is 2, 3, 5, and C is 1, 5, 5. Okay, so these are the vertices of the triangle. Okay, these are the vertices of the triangle. Triangle ABC. Okay, let's give name it as A, B, and C. Okay, ABC. Now, since they have given the points or position of the vectors, we can find out the position vector of each vertices, right? We can find the position vector. And what are the position vector? Vector OA is equal to I plus J plus 2K, I plus J plus 2K. Vector OB is equal to 2I plus 3J plus 5K. And vector OC is equal to I plus 5j plus 5k. Okay, so how will you find out area of a triangle? Area of triangle is equal to half of the magnitude of the cross product of two sides of triangle, right? Half of that is half of AB cross AC, where AB and AC are the adjacent sides of the triangle, right? This is a formula to find out the area of a triangle, isn't it? So what is this AB and AC? AB, here you can see that AB AC are the two adjacent sides. That's why we selected the sides AB and AC. But here we don't know AB and AC. We just know the position vector of those vertices, right? Only we know the position vector. How will you find out AB and AC from the position vector? It is easy, isn't it? How will you find out vector AB? Vector AB is equal to, we know it is position vector of B minus position vector of A. OB minus OA, right? And what is this OB? It is 2I plus 3J plus 5K minus OA is I plus J plus 2K. I plus J plus 2K. So that is 2I plus 3J plus 5K minus I minus J minus 2K. Now you subtract the corresponding components. 2I minus I is I. 3J minus J is plus 2J. Then 5K minus 2K is plus 3K. Alright, so this is vector B. Vector B is I plus 2J plus 3K. I plus 2J plus 3K. Alright, now moving on to our next vector, that is vector AC is equal to vector OC minus vector OA. Vector OC minus vector OA. What is vector OC? It is I plus 5J plus 5K minus I plus J plus 2K. Now, what you have to do? You have to open the bracket, that is I plus 5j plus 5k minus I minus j minus 2k. Okay, so this is the vector AC. And if you subtract the components I minus I, that is 0I, then 5j minus j is 4j, then plus 5k minus 2k is plus 3k. So that is equal to minus 4j plus 3k, minus 4j plus 3k. Is there any mistake here? Um, OC, it is OC minus OA, right? OC minus OA. And it is 5j. And what was j? 5 minus, it is actually 5 minus 1. That is 4j, right? Just 4j. It is not minus 4j. It is plus 4j, right? 5 minus 1 is 4j. I'm sorry. I made a mistake. So it is 4j plus 3k. So what is AC? It is 4j plus 3k. Now we have got the two adjacent sides AB and AC. Now what is the area of the triangle? Area of triangle is equal to half of magnitude of AB cross AC. And if you need to find this, first you need to know what is AB cross AC, right? We need to know AB vector AB cross vector AC. We need to know vector AB cross vector AC. So that is equal to determinant of ijk, that is first vector is 1 2 3, then 0, then 4, then 3, 0 and 4 and then 3. So that is equal to I into, it is 6 minus 12 minus j into, then 1 into 3 is 3 minus 0, then plus k into this is the row and column, then that is 4 minus 0. So this is equal to minus 6i, then minus 3j, then plus 4k. So this is the vector AB cross AC. I hope you know how to find out the determinant of 3 by 3 matrix, right? So that's what I have done here. Find out AB cross AC. That is, if you are taking the I, then you have to remove the first row and first column. Then you find out the determinant. Okay, determinant. Then you take the J component, you remove the row and column containing J. Then you find out the determinant of the remaining minor. Okay, that's how you find out the determinant of a 3 by 3 matrix, right? So that's how we got the vector minus 6i minus 3j plus 4k is vector AB cross AC. But we can't stop here. We need to know the magnitude of vector AB cross vector AC. So that is equal to root of minus 6 the whole square plus minus 3 the whole square plus 4 square. That is equal to root of 36 plus 9 plus 16. Right. So this is equal to root 61. It is root 61. And what about the area of the triangle? Is it root 61? If it was a parallelogram, we could have stopped there because we know the parallelogram, the area is nothing but magnitude of AB cross AC. But here it is triangle. Area of triangle is just half of that of the parallelogram, right? AB cross AC. So that is equal to half of root 61, which means root 61 divided by 2 square units. Since it's a area, we need square, unit square, right? So root 61 by 2 square units. All right. Now we are moving on to our next question. Find the sine angle between the vectors I plus 2j plus 2k and 3i plus 2j plus 6k. So you have given two vector. You have to find out the sine angle between these vector. How will you find out the sine angle between this vector? And what is it? So you have to connect what is the relation between vector and sine angle. It is coming in the cross product. We know vector A cross vector B is equal to magnitude of vector A into magnitude of vector B into sine theta, right? From that you will get sine theta. From that you will get sine theta, right? So we know the formula of sine theta from that. That is equal to uh, sine theta is equal to magnitude of A cross B. We need the magnitude because sine theta, we have to find out the value, right? So magnitude of A cross B divided by magnitude of A into magnitude of B. So this is a formula to find out the sine angle. All right. So here we need to find out, first we need to find out A cross B, right? So A cross B is equal to, how will you find out? IJK, determinant IJK, then you write the components. You write the components, that is 1, 2 and 2, then 3, 2 and 6. Okay, so this is equal to I into 2 into 6 is 12 minus 4 minus j into you remove this row and this column, that is 6 minus 6, then plus k into 2 minus 6, 2 minus 6. Okay, so I'm going to write the remaining part here. Okay, so this is 12 minus 4. 12 minus 4 is 8, right? 8i. Then 6 minus 6 is 0. So j component does not exist. 2 minus 6 is minus 4. So it is minus 4k. 8i minus 4k. 8i minus 4k is our vector A cross B. So vector A cross vector B is equal to 8i minus 4k. 8i minus 4k. Now what you have to do? You have to find out the magnitude of that vector. That was the numerator, right? Magnitude of vector A cross B is equal to 8 square plus minus 4 the whole square. That is root of 64 plus 16. That is equal to root 80, right? Root 80. We can write 80 as 16 into 5. So this one can be written as 4 root 5. It can be written as 4 root 5. Alright. Now what you have to do, you have to get the denominator also. And that is magnitude of A. Magnitude of A is equal to vector A is I plus 2j plus 2k. So the components are 1, 2 and 2. Right. Scalar components are 1, 2 and 2. Right. So that is 1 square plus 2 square plus 2 square. So that is equal to root of 1 plus 4 plus 4. That is root 9 equal to 3. We have got the magnitude of vector A. We need magnitude of vector B. That is root of 3 square plus 2 square plus 6 square. That is root of 9 plus 4 plus 36. Root 49, that is equal to 7. Root 49, that is equal to 7. Okay, so sine theta is equal to 4 root 5 divided by 3 into 7. That is 4 root 5 divided by 21. 4 root 5 divided by 21. So theta is equal to sine inverse of, since this is sine theta, we need the angle theta, right? Sine inverse of 4 root 5 by 21. So now we have obtained the sine angle between the vector A and vector B. Okay, so what were the steps that we have done? First, we found out vector A cross B. Then we found out the magnitude of vector A cross B. Then we found out magnitude of A and magnitude of B. And we know the formula to find out the sine angle. Sine theta is vector A cross B by magnitude of vector A cross B by magnitude of A into magnitude of B, right? On substituting those values, we got theta is equal to sine inverse of 4 root 5 by 21. Alright, now we are moving on to our next question. I hope this question was clear to you all. Now we are moving on to our next question. If vector A, vector B, vector C are 3 unit vectors, okay, they are 3 unit vectors such that vector A plus vector B plus vector C equal to vector 0. Find the value of vector A dot B plus vector B dot C plus vector C dot A. Okay, so A, B, C are 3 unit vector, which means the magnitude of, from that itself we get the first condition, right? The magnitude of A equal to magnitude of B equal to magnitude of C is equal to 1. And they have given that vector A plus vector B plus vector C is equal to vector 0. Find the value of A dot B plus B dot C plus C dot A. So here what you are going to do is that we are going to square these things. Okay. On both sides we are going to square it. So this will become vector A plus vector B plus vector C, the whole square is equal to 0. Okay, that whole square is equal to 0. Then how will you expand it? How will you expand it? Vector A plus vector B plus vector C into vector A plus vector B plus vector C is equal to 0, right? This was our condition after squaring. Right, now you have to do the multiplication like this, right? So that is first vector A dot vector A, then vector A dot vector B plus vector A dot vector C. Now what is the second step? Similarly, you have to multiply this vector B with each of these vector. So you will get vector B dot vector A plus vector B dot vector B plus vector B dot vector C, right? Now, what is the third step? You have to multiply C with all these vectors, right? So, vector C dot vector A plus vector C dot vector B plus vector C dot vector C is equal to 0. And what is this A dot A? We know by the property of dot product, we know A dot A is nothing but magnitude of A square, right? And A dot B, then we have a B dot A. Both are same, right? A dot B and B dot A, both are same, which means it is 2 into A dot B, right? Now, you take these two, A dot C and C dot A. Are they same? Yes, A dot C and C dot A are same. When it is cross product, they are different. A cross A and C cross A are different. A cross C will be equal to minus of C cross A. But here it is dot product. A dot C and C dot A both are same because we are doing scalar multiplication, right? So A dot C and C dot A, since both are same, we can write this one as 2 into A dot C. 2 into A dot C, which means we can replace the C dot A with A dot C also, which means there are 2 A dot C, that is 2 A dot C, plus then C dot B and B dot C. Both are same, right? Both are same vector. B dot C and C dot B are same. So this is equal to 2 into B dot C. Okay. Plus, what about this vector B dot vector B? That is equal to vector magnitude of vector B square, and vector C dot vector C is equal to plus magnitude of vector C square is equal to 0. All right. So what you have to do in the next step, this we can substitute the value because all these are unit vectors. So it will become 1 plus 1 plus 1 plus this we can take 2 outside. From this we can take 2 outside. 2 is common in both 3 of them, right? A dot B plus A dot C plus B dot C is equal to 0. All right. So we can take the next page. So that is equal to 3 plus 2 into A dot B plus A dot C plus B dot C is equal to 0. This was a previous step. All right. So I'm taking this 3 to the other side. 2 into A dot B plus A dot C plus B dot C is equal to minus 3. 0 plus 0 minus 3 is minus 3. Right. So hand 2 can also be taken to the right side. So this is equal to A dot C plus vector B dot C is equal to minus 3 by 2. Minus 3 by 2. And what was our question? We have to find out the value of A dot B plus A dot C plus B dot C. What is it? The value is minus 3 by 2. The value is minus 3 by 2. So this was also an important question that is asked in this session. Alright. Now, moving on to our next question. Let vector A, vector B, vector C are three vectors such that magnitude of vector A equal to 3, magnitude of vector B equal to 4, and magnitude of vector C equal to 5, and each one of them being perpendicular to the sum of other two. The sum of other two. Find magnitude of vector A plus B plus C. Okay, A, B, C are three vector. Their magnitudes are given. A, B, and C, it is 3, 4, 5 respectively. Each one of them being perpendicular to the sum of other two, which means vector A is perpendicular to vector B plus C. Okay. Similarly, vector B is perpendicular to vector A plus C. Similarly, C is perpendicular to vector C is perpendicular to vector A plus B. Okay. Alright, so we are going to write it mathematically. So the magnitude of vector A equal to 3, magnitude of vector B equal to 4, and magnitude of vector C equal to 5. And they have given that vector A is perpendicular to vector B plus C. Okay, so that is which implies vector A dot B plus C is equal to 0. Next one is vector B is perpendicular to vector A plus C, which implies vector B dot vector A plus C is equal to 0. Next, vector C is perpendicular to vector A plus B, so which implies vector C dot vector A plus B is equal to 0. So these are given in the question. We have got some conditions from that, right? Now what you have to do, we have to get the magnitude of A plus B plus C, right? So here also I'm going to find out magnitude of vector A plus B plus C. So for that I'm first finding out the square of that thing, right? So this is equal to, we know it is vector A plus vector B plus C into vector A plus vector B plus C. We have already done this one in the previous section, previous problem. So here also we can do it again. That is, first you find the product, then you multiply with the here I'm going to multiply it together. Okay, since the condition is A dot B plus C is 0, you don't need to first you don't need to multiply A with B and then with C, because in the first step itself, that is, if you multiply vector A dot vector B plus C, we know the result is 0 because it is given in the question. So you don't need to separately find out the product and all. Okay, that is, first you multiply vector A dot A, vector A dot A. Then you multiply this together. Take it as a team, B plus C. Then you multiply it with A. So which means A dot B plus C. Right? So why I'm doing like this is that because in the question they have given that A dot B plus C is 0. So we don't need to expand it and then simplify it to apply the condition, right? We can directly apply the condition A dot B plus C is 0. So I'm not taking the vector A to the inside of the bracket of B plus C. All right. So next step is we have to do it with B also. And here what you have to do, you multiply it with B, vector B. And we know if you multiply it with A plus C, the product is 0. So you write it like that. That is plus vector B dot B plus vector B dot A plus C. Okay, you don't need to expand that part. Only that way. Similarly, how will you do with C? Vector C dot C, you can write it as such. But vector C dot vector B plus or vector A plus A plus B. Okay, B plus A or A plus B. It is 0, we know. So write it as such. So this is equal to, this is magnitude of A square, right? Magnitude of A square. And this one we know it is 0 from the question. And this one is magnitude of vector B square. This one we know it is 0. And this one we know it is magnitude of vector C square. Plus this one is 0. Okay, so this is equal to magnitude of A square plus magnitude of B square plus magnitude of vector C square. So that is equal to 3 square. Since magnitude of A is 3, this 3 square plus 4 square plus 5 square. So that is equal to 9 plus 16 plus 25. That is equal to 50. Isn't it? It is equal to 50. But we need to get the magnitude of vector A plus B plus C. This was vector A plus B plus C the whole square. So you have to take the root of that, root 50. This can be written as root of 25 into 2. That is 5 root 2. That is 5 root 2. Moving on to our next question. If vector A equal to 2i plus 2j plus 3k, vector B is equal to minus I plus 2j plus k, and vector C is equal to 3i plus j are such that vector A plus lambda into vector B is perpendicular to vector C, then find the value of lambda. Vector A is given, vector B is given, vector C is also given, and an extra condition is that vector A plus lambda into vector B is perpendicular to vector C. Then you have to find out the value of lambda. When two vectors are perpendicular, we know their dot product will be equal to 0, right? That is, if A and B are perpendicular to each other, A dot B will be equal to 0. Here, which are the vectors that are perpendicular to each other? A plus lambda into vector B and C are perpendicular to each other. From that, what is the condition that you are getting? That is vector A plus lambda into vector B dot vector C is equal to 0, right? Since they are perpendicular, vector A plus lambda into vector B dot vector C is equal to 0. Alright, so from this, first you need to find out what is vector A plus lambda into vector B, right? So what is vector A? 2i plus 2j plus 3k. This is vector A plus lambda into, what is vector B? Minus I plus 2j plus k. Then 2i plus 2j plus 3k. If you are multiplying with a scalar, you have to multiply that scalar with each of the components of the vector, right? So this will become minus lambda I plus 2 lambda j plus 2 lambda k. This is A plus lambda into vector B. Okay, now what you have to do, you can add these components. That is 2 minus lambda into I plus 2 plus uh, 2 lambda, right? 2 plus 2 lambda into j. Then third is 3k. 3 plus 2 lambda into k. 3 plus 2 lambda into k. We have got A plus lambda into B. And we know since these vectors are perpendicular, A plus lambda B dot C is equal to 0. So A plus lambda was 2 minus lambda I plus 2 plus 2 lambda into j plus 3 plus lambda into k dot product with vector C. What is vector C? 3i plus j. 3i plus j is equal to 0. And here you can see this is the I component. So which means 2 minus lambda into 3. Dot products means just multiply the scalar components of the corresponding components, right? So 2 minus lambda into 3. Then j is 2 plus 2 lambda into 1 plus 2 plus 2 lambda into 1 equal to 0. Since here the k component is 0, 0 into any number is 0. 0 into 3 plus lambda is also 0. So there is no component over there. So this is equal to 0, which means you have to take it like this, right? 2 into 3 is 6 minus 3 lambda plus 2 lambda equal to 0. 6 plus 2 is 8. Then minus 3 lambda plus 2 lambda is minus lambda, that is equal to 0. Minus lambda equal to minus 8, lambda equal to 8. Lambda is equal to 8. So we have got the value of lambda. Alright. I hope this question was clear to you all. So we are moving on to the last question of this session. Alright. Show that the points A comma B and C with position vector with position vectors 3i minus 4j minus 4k, then 2i minus j plus k, and I minus 3j minus 5k respectively form the vertices of a right angled triangle. Okay, right angled triangle. So these are the points A, B, C, and their position vectors are given here. 3i minus 4j minus 4k, 2i minus j plus k, I minus 3j minus 5k. It forms the vertices of a right angle triangle. And what is the peculiarity of a right angle triangle? One angle is 90 degree. One angle is 90 degree, isn't it? So which means if you consider any two sides, and if their dot product is equal to 0, we can say that those two sides are perpendicular to each other, right? So if two sides are perpendicular to each other, we can definitely say that it is a right angle triangle. Perpendicular means 90 degree. The angle is 90 degree. So we can say that it is a right angle triangle. Okay, so first we need to find out the sides of the given triangle. First we need to find out the sides of the given triangle. It is ABC, which means you have to find out AB, BC, AC. And if you find out AB dot BC is equal to 0, then we can say that AB and BC are perpendicular to each other. So we can say that one angle is 90 degrees. So definitely that triangle will be a right angle triangle. Or you can take AC and BC, then you find the dot product. If AC into BC dot product is equal to 0, we can say that AC and BC are perpendicular to each other. So we can conclude that one angle is 90 degree. So that triangle will definitely be a right angle triangle. All right, I hope that everybody got the concept of that question and how we are going to solve that question. All right, so first we have the position vector OA is equal to 3i minus 4j minus 4k, and then OB is equal to 2i minus j plus k. Then OC is equal to I minus 3j minus 5k. So these are the vectors. Now, first, we need to find out the sides of the triangle, right? So first we can find out vector AB. Vector AB is equal to, we know it is OB minus OA. It is OB minus OA. What is OB? 2i minus j plus k. 2i minus j plus k minus 3i minus 4j minus 4k. Alright, so this is equal to 2i minus 3i, right? Sorry, it is minus j plus k minus 3i plus 4j plus 4k, because we have to change the sign because we are multiplying with the minus outside, right? So the sign changes within the bracket. That's it. 2 minus 3, that is equal to minus I, then minus plus 4, minus 1 plus 4 is plus 3j, right? 1 plus 4, it is 5k. It is 5k. So what is the vector? Minus I plus 3j plus 5k is the vector. Minus I plus 3j plus 5k is the vector. And what is vector AC? Vector AC is equal to vector OC minus vector OA. Vector OC minus vector OA. So that is equal to I'm sorry, it is equal to I minus 3j minus 5k minus 3i minus 4j minus 4k. Okay, so this is OC minus OA. OC minus OA. So that is equal to I minus 3j minus 5k minus 3i plus 4j plus 4k. Okay, so I minus 3i is minus 2i, minus 3 plus 4 is plus j, minus 5 plus 4 is minus k. So this is vector AC. Minus 2i plus j minus k is vector AC. Okay, so let's check whether AB dot AC is equal to 0. If AB dot AC is equal to 0, we can conclude that AB is perpendicular to AC, and then ABC is a right angle triangle. If it is not 0, you just find out the side BC, vector BC also. Then you find the dot product with any of the sides, and if you get 0, you can say that it is perpendicular to each other. So we can conclude that it is a right angle triangle. Okay, here I'm just finding out two sides. Let's see whether the dot product is 0. Then we can stop here itself, right? AB dot AC. I'm going to find out AB dot AC. AB dot AC is equal to, what was our vector AB? It is minus I plus 3j plus 5k. Okay, dot product with AC. AC is minus 2i plus j minus k. So how will you do the dot product? Just multiply the corresponding components, right? Corresponding components. Minus I into minus 2, right? So it is plus 2. Then 3 into 1, it is plus 3. Then 5 into minus 1, that is minus 5. All right. So it is 2 plus 3 minus 5, right? We have multiplied the corresponding components of I, j, and k of both the vectors, right? That's how you find dot product of two vectors. So this is 2 plus 3 minus 5, that is equal to 5 minus 5, right? This 5 minus 5, that is 0. That is equal to 0, which means AB, vector AB dot vector AC is equal to 0. From this, what can you conclude? The dot product of 0 means vector AB is perpendicular to vector AC. Vector AB is perpendicular to vector AC, which means one angle of the triangle is 90 degree. If one angle of a triangle is 90 degree, then we can definitely conclude that triangle ABC is a right angle triangle. Isn't it? Triangle ABC is a right angle triangle or right triangle. All right. So these are some of the important questions that are asked in 3 mark session of your question paper. So I hope this session was useful to you all. Until then, thank you.